Hello everyone, I'm Sanchari. I and my group members, Kaustav, Shivani, and Ananya, today are going to talk about our programming language by the name Kaja. So let's start. Our programming language goes by the name Kaja and has the following top features. Firstly, it's dynamically typed. So by dynamically typed, the great thing about our language is that even though we have the constructs for float, integer, string, and bool data types, we don't explicitly need to mention it when we are declaring our variables. Along with that, we have the platform-independent feature that allows us to create an intermediate code that basically takes support from a symbol stack and generates itself, and that is later used along with a symbol table to generate the runtime. We will get into that in a while. The other special functionalities we have are the added features of an array as a data structure, and we have user-defined functions which we are expressing as parameterized and non-parameterized functions. We have also provided the provision of passing the program through the command line. So these are the features we talked about, like data types that we have. Along with the loops, we are providing a for loop, which is in our language expressed as a repeat, to, and till, and conditional statements of if and if-else constructs. Along with that, we have operators for most basic functionalities, which are relational, binary, and assignment operator. Added functionalities we have is a dynamic array and the built-in functions and the user-defined functions. Next, let's have a brief look at our grammar. So, if we look at this is our grammar. That is what we have used for generating our programs. So like every other programming language, a program is a series of statements which we have here expressed as the umbrella term called the statement list. And the statement list goes about decomposing into like atomic parts. So we have a statement here which is again a declaration, a club of declaration, assignment, print, conditional, relational, so on and so forth. So here if I come to my parser, this parser is generated by ply, which will be later discussed by my friend. So for now, ply creates the lexer and the parser, and from the lexer we get a set of tokens which comes as an input to the parser. Now the parser takes these tokens and acts as a tokenizer, passing these tokens in forward to AST to be used during runtime and also for providing the result. So let's take a brief look at what is happening here. So we have the statements which I have expressed as a series of instruction list, and then we have like definitions or functions for statement, identifier, primitive, and I have other constructs like functions for binary expressions, Boolean operators, print statements, assignable, a lot of things, such things. So if I come to something better, like say a function call, a function definition, as you can see, like in our language, we have a function definition which is expressed as like it has to be defined by fun and then identifier, r parenthesis. So all these are basically tokens, and based on the order in which they're occurring, they're labeled as 1, 2, 3, 4 index positions, and these are what I pass as tokens to the AST, or the abstract syntax tree. So this abstract syntax AST over here stands for abstract syntax tree, which is basically a class, a set of classes and set of functions. It's kind of like an object-oriented programming way. We have programmed it in Python, and it handles all the classes that is being called. It's like kind of like a listener, if you can consider it, and then it takes the values and then it puts them in a symbol table, and from the symbol table it uses those values to generate results during runtime. Also, this AST along with an intermediate code generator works for generating answers in the runtime. So apart from functions, we also have constructs for array access. So like I showed you, this identifier over here is like 1 and then 2 and 3 and 4 and so on and so forth. So for the array access operation, I really need the identifier and I need the particular expression, say arr of I. So that is what I'm gonna pass. So moving on, this lexer and parser will be even better discussed and brought about by my friend Kaustav. So let's go to that. Thank you.
Hi, I'm Kaustav and I'm going to explain to you how Ply works. So Ply is a pure Python implementation of the popular compiler construction tools Lex and YSCC. So Lex and YSCC are the basic tools which form the basis of a compiler, that is a lexer and a parser. But we are using its Python wrapper, which is Ply. Ply consists of two separate modules, lex.py and yscc.py. So we have to create our own lexer and parser on top of Ply. So I'm going to show you how a lexer looks like. So we go to a module, which is a language Kaja, SCBL, lexer.py. So this is our Alexa. As you can see, we have our keywords if, else, display, repeat, to, while, return, and fun. And these are the specific keywords in our language. And then we have words for defining in grammar, like we have a right parenthesis, a left parenthesis, a divide, a times. These are just for using tokenizers in grammar. And this is our parser.py, which Sanchari has already explained to you, but I'm just going to give you an overview about that. So for example, let's take an if else statement, and Alexa gives us the tokens, and these tokens are passed to the AST for evaluation. So we can see this is token number 1, 2, 3, 4, 5, 6 respectively. So expression is passed to the AST, and the sixth statements is passed to the AST, and statements again are passed to the AST. We don't really concern ourselves with the if and parentheses. We just consider that the statements, identifiers, and the primitive data types associated with those. And finally, I'm going to show you the main important thing, how to install the language. And so this is the readme, as installation instructions are clearly given. uh, First of all, we need a python, we need python in a desktop. It should be python 3 specifically. We have to go to this link to install that. Then we need pip, which is the python package manager. And then I have created a requirements.txt file, which generally installs all our requirements. And currently there is no such requirement except for a ply file. I'll just show you the requirements.txt. This is a requirement.txt which has a Ply version 3.11. If we run this command, pip install our requirements.txt, our all dependencies will be resolved. And to run any program, we just have to write Python, the executor kaja.py, and the program example.kaja. .kaja is just a file in Kaja language. So I'll just show you a particular program. For example, this is a program having nested loop. These are two nested loops, starts with G1 to 7, and it starts with identifier H, which again goes to 1 to 7. If I run this, well, you gotta get the output. This is how we run the program. Oh, so this is, I ran the program in Python 2, and so for that specifically we need Python 3. That's why we get the following error. See, we get printed accordingly. So this is how our language is installed and ran. Next, Ananya will continue and explain something about.
Hi everyone, this is Shibani. I'm going to continue the presentation with uh, introduction to intermediate code generation in our compiler. So this is the next step where we are using the format of 3 address code for intermediate code generation. The name derives from the fact that every instruction is converted to a 3 address instruction where each instruction is reduced to three operator and 2 operands. So this is a mechanism for optimization in compilers. In order to generate intermediate code in a 3 address format, we're using a symbol stack in our compiler, where we are storing all those parsed symbols from the parser, and we iterate through all of them and generate intermediate code. I'm going to show you an example using an example program. This is an example program that we've written where there are all kinds of operations, like there's an expression with more than one operator, and there are print statements, and there are assignment statements, and there are loops, the different kinds of loops that we've implemented in this language: the if loop, the while loop, and the for loop, named as repeat. I'm just going to run this. In the same way that Kostov showed before, and we can see the generated output, and I'm going to show you how the intermediate code for this program is going to look like. So this is how it's going to look like. So like I mentioned before, every instruction is converted into a 3 address format, and it's usually at most 3 address, the breakdown is usually 3 components and not more. And the loops, like you can see, are reduced to in the form of go to and jump statements, like the if the condition checking happens here, and accordingly there's a go to, a jump to the respective label. Like here, if the condition is false, then it directly jumps to this label. If not, it goes through the body of the if statement, which is this statement. So and the other thing that I want to show is, in the example program, we had one instruction which was an addition of 3 operands with multiple operators, and that's going to look like this, where the execution happens in a like breaks down into the first operator execution, followed by its result collection in another variable, and that's going to be used in the next step. So this is one mechanism how using which the compilers can optimize the execution, because it brings in it simplifies the code execution, and that's the main purpose of intermediate code. And I'm going to hand over the presentation to Ananya to continue forward.
Hello everyone, I'm Ananya, and so far my fellow groupmates have talked about the entire code flow and the grammar and how our language basically works. So as you have already seen that the grammar is fed into the lexical analyzer, which is then used for tokenizing, and finally the tokens are used as an input for the parser, which is then used by the runtime environment to finally produce the output. So now I'm going to talk about some of the added features that we have added to our language. So apart from basic operations, looping, and conditional statements, we have also implemented array list, which can be defined dynamically. And apart from that, we also have support for user-defined functions. So now I'm going to show you the code for the arrays. So that is sort.kaja. So I'll just open up the code. So as you can see, here I have an array containing 7 elements, and I have a built-in function called array push, which is basically used for appending an element in the end of the list. So I have a total of 8 elements now, and then I perform a simple bubble sort for sorting the elements, and then finally I'll be displaying the array contents, which will be basically a sorted list. Now I'm going to run this function, and let's see if it is able to sort the elements properly. So as you can see that our function has been able to sort the numbers in ascending order. So we can see that our array and our sorting mechanism works. Now we'll be moving on to function calls. So for function calls, we have a program called max.kaja. So I'll just show you the file. So here you can see that I have a function defined as find max, which I'll be calling from here, find max, and I'm passing two parameters x and y. So I have set the value of x to 20 and the value of y to 40, and then I'll be performing a simple condition to check whichever is the maximum and then return the maximum value. So let's try running this program. And let's see if this works. Yeah, so as you can see that it does work properly and it returns the maximum value that was 40. So we can see that this works. Now I'm going to show you a few built-in functions. So we also have support for some of the built-in functions such as array append, array insert, and other mathematical functions as well. So I'm going to show you how array insert works. As you have already seen in sort.kaja that we have used array append for appending an element at the end of the list. So now I'm just going to modify this and show you how array insert works. So what I'm going to do is I'm just going to call the insert insert, and so the syntax for insert is the array name and then the position where you want to insert. So I think so I'm going to insert at position, let's say 2, and I'm going to insert value 80 in that. And now I am just gonna remove this part altogether and just display whatever is there in the array. So I'll just remove this part. Yeah, so let's see now if 80 is inserted at position number 2. So I'm going to save it and run sort. Yeah, so now you can see that 80 has been inserted as at position number 2. So this is working, and now I'll be moving on to other mathematical functions such as tan, cos, etc., which my fellow groupmate Costa will be explaining. So I'll be handing over to Costa. Thank you.
Hi, I'm Kaustav. I'm going to explain you the rest of the miscellaneous functions which are there in our language Kaja. So let's see which folder we are. We are in this folder, and I open this file, and we can see these functions like display int, display float, log of 0.4, sine of 1.4, and then there is a power function, as you can see, power of 2 comma 3. Then there is a random function. This function generates any random number. The function at line number 9. This is 1 greater than 2. Obviously the value will be outputted. And there is a function called argv. Argv tells us the environment which we are in. And then there is a square function, square of 2, which should return 4, obviously. And then these little guys which you see, the TA, the teacher, and the founders, we just added them just for some fun, and you can see their result when I run the program. Then there is a queue function as well. So let me run this program. Yes, just you can see the outputs of the various functions. This is the environment which I am talking about, the argv function. And this is the first argument, this is the second argument, this is our teacher Xianghu, and this is our teacher Mr. Bansal, and these are the founders, of course, we of the language, Kaustubh, Shivani, Sanjari, and Ananya. Thanks a lot for hearing us, and happy coding. Thank you. Bye bye.